In this video, we're going to work on task 3, which is the Pythagorean theorem for square, part 2. In this one, we are using the Pythagorean theorem in order to find a missing leg instead of the missing hypotenuse. So the concept is still the same. We still have a right triangle. Remember your right angle, and across from that is the hypotenuse, and then the two adjacent sides are called legs. In a right triangle, you can relate the three sides with the Pythagorean theorem. A squared plus b squared equals c squared. So the square of the sum of the squares of the two sides is equal to the square of the hypotenuse. So the most important thing that we do is first determine which one is the hypotenuse. The legs, a and b, are interchangeable. So let's take a quick look at a worked out problem. You don't need to write this one down. You just need to kind of pay attention as we're going. We're finding the length of the missing leg. So notice here, our C, the one across from our right angle, is 10. And then we're calling A the 8 and B the X. We will still just plug in like we did when we were doing the hypotenuse, missing hypotenuse. Then we'll square, and right here's the difference. When we are looking for a missing leg, we'll first need to subtract from both sides in order to get that x squared by itself. And then we finish by taking the square root. Remember, we are still just using the positive answer because this is a length, and the negative answer doesn't make any sense. All right, here's where you're going to start writing because we're going to do examples 1 and 2 together. Go ahead and copy the first triangle. And we are looking for the length of the missing leg. So again, our first step should always be to go across from the right angle to label your hypotenuse C. And I should back up and say, I know I can use the Pythagorean theorem here because it's a right triangle where I know 2 of the 3 sides. So the 5 is my C, B is already labeled, so my A is 3. My Pythagorean theorem, and then I'm going to substitute in. So I'm going to put 3 in for A. I don't know B, so it's going to stay B. And I'm going to put 5 in for C. So nothing has changed from when we were doing this to find the missing hypotenuse. Now I'm going to do my exponents as I simplify each side. And then right here is where things change. I can't do my addition because they're not like terms. One's a variable, one's not. So I want to solve for my variable by using my inverses. So I'm going to subtract 9 from both sides. I get b squared equals 16. And I don't want b squared, I want b. So my final step is to take the square root. Normally I'd do plus or minus b, plus or minus 4. But since this is length, the negative does not make sense. Let's take a look at example 2. Again, take a second to go ahead and copy the triangle. And let's determine our C. So C is the 8 because it's across from the right angle. A is labeled, and this time I'm looking for B. Again, it's a right triangle, so I know I can use my a squared plus b squared equals c squared. The a is the one I don't know. I'm going to plug 3 in for b. Sorry, I made a little mistake there. Let's fix that. I'm going to plug 3 in for b. And I'm going to plug 8 in for c. I can do my exponent to simplify each side. And then again, I can't do my addition because they aren't like terms. So I'm going to subtract the 9 from both sides to get the a squared by itself. And then I'm going to take the square root. Now this one's not a perfect square, so I'm going to have to go to my calculator to finish. So I'm going to go to my calculator. I'm going to do 55. I'm going to hit the square root key. And what I get is 7.416198, and it does keep going. Notice it says to round my answer to the nearest tenth. That's 1 decimal place. So I'm going to underline the tenth. I look to the right. The 1 tells me to stay the same. So I get 7.4 as my A. Now you are going to go in and do 3 and 4, and then we will correct them together tomorrow.